Yesterday we covered solving systems with the elimination method, linear combinations method, and this is just more practice, but it's notice it's 6.4, not 6.3. The only difference between the sections is that 6.4, you're going to have to actually modify one equation or maybe both equations to get something to cancel. So our assignment for today is to do 1 through 11 odd. Of course, I encourage you to do more if you want to. But at the very least, let's do 1 through 11 odd. So let's just get started here on number 1. Is it ready to combine the lines? No, it's not. Because if I combine 2 and 3, I get 5x. That doesn't work. I mean, it doesn't cancel. And -1 and -2 is -3y. It doesn't cancel. So we need to modify one or both equations to get a variable to cancel. So the question is, you need to decide which variable to cancel. You either cancel out the x's, which means you'd have to modify both because the 2 and the 3 don't cancel. You'd have to change this to become like +6, and you'd have to change this to become -6. You could do that, modify to cancel out the x's, or the easier option is to modify this to become a +2y. That way it'll cancel with the -2y. So you always need to think about what you're going to do before you actually do it. Go for the quicker path, the easier path. So the quicker path is to modify the top equation to get the y's to cancel. So I'm going to multiply the top equation by what? By -2, that's right. So when I distribute -2 times 2x, let me zoom out a little. -2 times 2x, that's -4x. -2 times -y, that's going to be a +2y. And -2 times the -1 over there is going to be +2. Now the bottom equation, we're just going to rewrite it. 3x minus 2y equals 1. And now we really are able to combine the lines and eliminate the y's. The y's eliminate. When I combine the -4 and the +3x, that gives me a -1x. The equal sign comes down, and 2 plus 1 is 3. So my final answer there is x equals -3. Bless you, by the way. So that's one answer. We need the other answer. All we have to do is plug it in, right? And you can plug it into any equation you want. Which one looks a little easier to plug in? Top. Okay, so let's go with the top equation. The top equation says 2x. So I'm going to start 2, but instead of x, I'm going to put the -3 that x actually equals, right? X equals -3, so I put the -3 in there. And then it says minus y, right? Up here it says minus y equals -1. Let me rewrite that. Minus y equals -1. And now let's actually do the math. 2 times -3, that is -6. Let's bring down the minus y, the equals, and the -1. Now I need to solve that equation by getting rid of this -6 by doing the opposite, which would be +6. And what you do to one side, you do to the other side. So now I'm almost done. I have a -y equals +5. -1 plus 6 is +5. Now you don't want a -y, so you're going to have to change the sign and change the sign. The actual math you're doing is dividing by -1, dividing by -1. So your answer is y equals -5. Cool? All right, let's move on. Jumping to number 3. Right here, I guess you could cancel out x's, but you would have to change this top x to a 35x, right? 7 and 5, you could change both of them to 35, and you have to change this one to a -35. That'd be modifying both equations, but there's a slightly quicker path. The quicker path is to do what? Cancel out what? The y's, okay? Because this is a 4y, and this is an 8y. This 4y could easily be changed to what? -8, right? And how would I change this 4y to a -8y? Multiplying by -2, that's right. So let me actually do that to get the y's to cancel. Like I said, if you wanted to, you could cancel out the x's. It'll just require more work. Canceling out the y's here, we're going to multiply the top one by -2, and we're going to get a new equation that says -14x minus 8y. Again, I'm just distributing this -2, and then -2 times -4, that's +8. So my new equation above is -14x minus 8y equals 8. The bottom equation, I'm just going to rewrite it. 5x plus 8y equals 28. And now it really is ready to combine and eliminate the y's again. So the 8y and the negative 8y cancel out. The negative 14 and the positive 5x, that gives me a negative 9x equals, and 28 plus 8 is 36. So I have this simple one-step blue equation. All I have to do is divide by negative 9 to get the x by itself, and my answer is x equals negative 4. That's one answer. I need the other answer. All I need to do is plug it into any equation I want. I'm going to go for the bottom this time. The bottom equation, as you can see, reads 5x plus 8y equals 28. I'm just going to replace this x with parentheses. So 5 parentheses plus 8y equals 28. And inside of those parentheses, I'm plugging in the x value of negative 4. This negative 4, I'm just plugging it in right here. And then I'm going to solve this equation. 5 times negative 4 is negative 20. Bring down the 8y, bring down the equals and the 28. I need to still get the y by itself, so I'm going to add 20 to get rid of the minus 20. What I do to one side, I do to the other side. 8y equals 48. Final step would be to divide by 8, and y equals 6. And of course, all these should be written in ordered pair form as a coordinate. I haven't been doing that, sorry. So this is the way your answer should be, negative 4, comma 6. So we're doing the odd ones here. And number 5 is the first one where we have to modify both equations. Okay, on the other ones, we've had the option, we thought about it, and we chose the quicker path, which was just modifying one equation. But right here, if you wanted to cancel out x's, this would have to be positive what? 15, and this would have to be negative 15, right? If I wanted to cancel out the y's, what would this have to be? Positive 6, and this one? Negative 6. So no matter what way you slice it, you're going to have to modify both equations, yay? So let's actually do that. Let's modify both equations. But before we do that, what do you guys want to cancel out? X's or Y's? Y's look a little bit nicer, right? Getting a positive 6 and a negative 6 is probably a little bit nicer than getting a positive 15 and a negative 15. So let's cancel out Y's. So with that in mind, we're going to change the 2y to become a positive 6 by multiplying by 3. So let's distribute the 3 into the top equation, producing a new equation over here. It's actually not a new equation. It's the same thing. It just looks different. 9x plus 6y equals negative 27, distributing the 3. Now we said we wanted to cancel out y's, so on the bottom, we're going to multiply the whole bottom equation by what? 2. That way, this negative 3y will become a negative 6y, which will cancel with the positive 6y. So let's distribute that 2 to each and every term. 2 times 5, 10x. 2 times negative 3, negative 6y. And 2 times 4, positive 8. And now we are ready to combine the lines and eliminate, once again, the y's. So what do we have left? We have a 19x equals negative 19. Final step, divide by 19, and your answer is x equals negative 1. That's one answer. You need the other answer. Let's plug it into any original equation you want. I'm going to plug it into the top one. You could do the bottom if you want. You're going to get the same answer. I'm going to go with the top. 3 times x plus 2y equals negative 9. But instead of x, I'm going to put parentheses. So 3 parentheses plus 2y equals negative 9. Inside of those parentheses, I'm going to plug in the x value of negative 1. Then I'm going to solve it. 3 times negative 1 is negative 3 plus 2y equals negative 9. To get rid of the negative 3, I'm going to do the opposite, which is plus 3. What I do to one side, I do to the other. I end up with, let me rewrite it, 2y equals negative 6. Final step would be to divide by 2. Divide by 2. My answer is y equals negative 3. So as an ordered pair, negative 1 comma negative 3. So on number 7, it does require a lot of work, not a lot, but a significant amount of work before you could even combine the lines to get a variable to eliminate. Because as you can see, if you combine these, it gives you 8x, it doesn't eliminate. If you combine the y's, it doesn't eliminate either. So you got to think, you need to choose which variable you want to eliminate first. So everybody should be looking at number 7 along with me, and everybody should be working on this together. So do we want to cancel out the x's? Let's say this. If I wanted to cancel out this x with this x, what number would this have to be if I have a 3 right here and a 5 right here? What number would this have to be?
15.
Positive 15. What would this have to be? Negative 15. So that's one option. Or if I wanted to cancel out y's, what would I have to change this positive 4 to? 12. And how about this negative 3? Negative 12. So it's up to you whether you want to cancel out the x's by changing both of them or the y's by changing both of them. Okay? So which one do you guys want to cancel out, x's or y's? Y's. Okay. So let's cancel out y's. I need to change this top equation. I need to change this top value to become, we said 12, right? So how am I going to change this positive 4y to become a positive 12y? By multiplying everything by, I want to go positive 3 to make it a positive 12. Now, there's many roads to the same place. You might have multiplied by negative 3 to make that a negative 12, and then down here you could change it to a positive 12. But because this is already positive, and this one's already negative, I'm just going to multiply this by 3 so it could become positive 12. And down here I'm going to multiply by 4 so it could become negative 12. It's already negative 3. So on the top, I want to end up with 9x. I want to end up with plus 12y. I want to end up with 3 times 27. That's 21 plus 60. That's 81. Did distributive property in my head. Of course, you could use a calculator. And then on the bottom, we're going to multiply this bottom equation by a 4. That way, this negative 3 will become a negative 12. That way, it'll cancel with the positive 12 that we already have. So let's distribute 4 times 5x. That is 20x. 4 times negative 3y. That's negative 12y. 4 times 16. That's 64. Thank you. And now this new red system of equations, it's the same system, it just looks different. I modified the equations. But now this system is ready to combine and cancel. So if I do combine the 9 plus 20, I end up with 29 of those x's. And of course the positive 12y and the negative 12y, they eliminate. That's why it's called the elimination method. And last but not least, the equal sign comes down. 81 plus 64. That is 145. Yeah. Okay? So we have this simple one-step equation to solve by dividing both sides by 29. And with the calculator, the answer is 5. X equals 5. So you have one answer. You still need the other answer. All you have to do is plug it back into any original equation. I'm going to go for the top equation. Top equation reads 3x plus 4y equals 27. I'm going to put 3 times parentheses so I could plug in the 5. So let me rewrite the whole thing. 3 times parentheses plus 4y equals 27. And I'm plugging in the 5 right in there. And 3 times 5 is 15 plus 4y equals 27. I need to get rid of that 15. I'm going to subtract 15, and I'm going to end up with 4y equals 12. So my final step would be to divide by 4, which means y equals 3. So my answer to the system as an ordered pair is the x value 5, the y value 3. Of course, if you have more time, plug it back in to double check your answers. Let's try number 8 and 9 are actually explained on a different video of decimals and fractions. I want to jump to number 11. On this one, we need to decide if we want to cancel out x's or y's. What do you guys say? What's the easier path, canceling out x's or y's? I would say y's. Now, you could cancel out x's, but if you wanted to cancel out the x's, this 3x would have to become positive 6x. This 2x would have to become negative 6x. So you'd actually have to modify both equations, right? But if you look at the y's, well, if you modify this to a negative 6, then it's ready to cancel with the positive 6. I mean, so there's many roads to the same place. And we've been canceling out y's this whole worksheet. Maybe we do want to cancel out x's just for fun. What do you guys say? Cancel out x's? No. No? You guys want to go for the quicker path always? Okay, quicker path always. Let's cancel out those y's by multiplying the top equation by what? Negative 3. To convert it to a negative 6y, of course. So let me distribute negative 3 times 3x. That'll become negative 9x. Negative 3 times positive 2y. That'll become a negative 6y. Negative 3 times positive 11. That's going to become a negative 33. There's my red equation up there. That's the new modified top equation. Now the bottom equation, we're going to leave it exactly the way it is. 2x plus 6y equals negative 2. And now it really is ready to combine and cancel. The negative 9x plus 2x, that is a negative 7x. And of course the negative 6y and the positive 6y, that eliminates. Bring down the equal sign. And we do have negative 33 minus 2. You owe 33, you owe 2, you're going to owe 35 altogether. So that is a simple one-step equation right there in blue. All we have to do is divide by negative 7. And we will have x equals positive 5. You have one answer, you still need the other. Let's plug it back into any equation you want. I want to go for the bottom equation. Bottom equation reads 2x plus 6y equals negative 2. I'm going to write 2 parentheses plus 6y equals negative 2. And of course, I'm plugging in the 5 right in there. So I have a new equation that reads 10 plus 6y equals negative 2. All I need to do is get rid of that 10 by subtracting 10, subtracting 10. I will have 6y equals negative 12. Final step would be to divide by 6, which gives us our final answer, y equals negative 2. So this system has an answer. The answer is the coordinate 5, negative 2. So number 12, as you can see, it's not ready to combine and cancel. The x's, if you wanted to cancel out the x's, you'd have to change both this top x and this bottom x. What would you have to change this top x if you wanted to cancel out x's? This would have to become, I would change it to a negative 6. Because 2 and 3, the number that they could both change to is 6. Since this is negative already, I would change this to a negative 6. I would multiply this by 3 to change to a positive 6. Then the x's would cancel out. However, that's not the easiest option here. The easiest option would be to cancel out y's. Why is that? Because this is a negative 4y down here. And this positive 2y, you could easily change it to a positive 4y. That will cancel, right? All you have to do is multiply the whole top equation by what? 2. By 2, that's right. So let's do that. Let's go with the quicker path. Multiplying the top equation by 2. And we're going to distribute it. 2 times negative 3x is negative 6x. And then 2 times 2y, that's positive 4y. And 2 times negative 15, that is negative 30. And the bottom equation, we're going to leave it exactly the way it is. Rewrite it, 2x minus 4y equals 26. And now it really is ready to combine the lines and eliminate the y's in this case. So the y's cancel out. The x's, the negative 6x and the positive 2x, that becomes negative 4x. Bring down the equal sign. And negative 30 plus 26, that's negative 4. So you have that simple one-step equation in blue right there. All you have to do is get the x by itself. So let's divide by negative 4, divide by negative 4. Your answer is x equals positive 1. You have one answer. All you need is the other answer. So take the value of 1 and plug it into any equation you want. I want to go with the, which one, top or bottom? Bottom, okay. So I'm going to take the 1 and I'm going to plug it into the x spot right there. So I really have 2 parenthesis minus 4y equals 26. I'm plugging in the 1. So that's really 2 times 1, which is 2, minus 4y equals 26. And now I need to get rid of that 2, so I'm going to subtract 2. I do to one side, I do to the other. I will have negative 4y equals 24. Final step would be to divide by the negative 4. Divide by negative 4. Negative 4's disappear. Y equals negative 6. So your answer to the system is 1 comma negative 6. 1 negative 6. Of course, this is your x value, this is your y value. If you have time, you could take your x value and your y value and plug them into x and y and see if it does give you negative 15. Or you could take your x and y, plug them in down here and see if it gives you 26. That would be the double checking part. So throughout this video, we've been modifying systems to be able to solve them. Sometimes we're able to just change one equation, right? And then we could get something to cancel. But on other situations, we have to modify both top and bottom equation, like on number 7. In order to cancel out the y's, I have to multiply the top equation by 3 and the bottom equation by 4. That's the only way to cancel. Sometimes you have to modify both equations, sometimes just one. So I hope that helps.